If two events, A and B, are not mutually exclusive and are in the same sample space, then the probability of these two events occurring is P of A or B equals probability or P of A union B, which is equal to P of A plus P of B minus P of A intersection B. And if event A intersection event B is a null set, then event A and event B are said to be mutually exclusive events. So, P of A or B is equal to P of A union B equals P of A plus P of B. So you will notice that for the two events that are said to be mutually exclusive, to get the probability of their union, there is no need to subtract the sum of the probabilities of this event by the probability of their intersection, since there is no common element from the two events. While for those two events that are not mutually exclusive, there are some common elements from the two events. So we need to subtract the sum of the probabilities of the two events by the probability of their intersection. Now let us take some examples. Suppose you have a spinning wheel, and the spinning wheel is divided into 12 sectors and numbered from 1 to 12, which means each sector is numbered. Now, since there are 12 sectors, each sector is numbered from 1 to 12. The outcomes in each event were listed below as set. For event A, the elements are 1, 3, 5, 7, 9, 11. For event B, its elements are 2, 4, 6, 8, 10, 12. For event C, the following sectors as its elements are 2, 3, 5, 11. Event D, the elements are 1, or the outcomes are 1, 2, 3, 4, 5, and 6. Event E, the elements are 1, 4, and 9. And finally, for event F, the elements are 1 and 8. Now, with these given events, we are to find the following. The first one is find the probability of the union of events A and B. Number 2, the probability of events of the union of events C and D. And for the third, the probability of the union of events E and F. For number 1, our solution will start from determining the intersection of the two given events. So A intersection B. So we refer to the elements of these two involved events and look for some elements that are common to both A and B. And since there is no common element from the two events, therefore the result is an empty or null set, which is denoted by the symbol phi. You can also use the open and close braces to denote an empty or null set. So what does this mean? Events A and B are mutually exclusive. Therefore, the probability of A union B is equal to P of A plus P of B. Now, substitute the value of the probability of each term. So for the probability of P of A, we refer to event A and count the number of elements. And since there are 6, that will be the numerator of the value of P of A. 6 over the number of sectors of a spinning wheel, which is 12. 12 sectors, so over 12. Now, for the probability of event B, we also count the number of elements from this set, which is also 6 over the number of sample space, or the sample space, 12. So if we get the sum of the two fractions, 6, 12, the result is 12 over 12, or that is equal to 1. Number 2, for the probability of the union of events C and D, we also need to determine the intersection of these two events. So C intersection B has the following elements: 2, 3, and 5, since these elements are common to both C and D. So since there are common elements from both events, these events are not mutually exclusive. Therefore, for the probability of the union of these two sets, we have P of C plus P of D minus P of their intersection. Now, let us determine the P of C. We refer to event C, and there are 4 elements. So that will serve as the numerator for the value of P of C. So 4 over the sample space 12. Then P of B plus P of D. For set D, there are 6 elements. 1, 2, 3, 4, 5, 6 over 12. Minus the probability of their intersection. And how many elements do we have for the intersection of event C and D? There are 3. 1, 2, 3 over 12. Then we combine the first two elements and subtract the result by 3 over 12. Therefore, we have 7 over 12 as our answer to number 2. Next, number 3. The probability of the union of events E and F. We also need to find out the intersection of these two events. So refer to the two sets. You will notice that their common element is 1. Therefore, E union F has only one element, that is 1. How many elements? It's also 1. Therefore, such pair of events are known as not mutually exclusive. So for P of the union of E and F, we have P of E plus P of F minus P of their union. Now for P of E, we know that set E has 2 elements, so that is 2. Yeah, 3 I mean, so that is 3 over 12. Plus P of F, F has 2 elements, so that is 2 over 12. Minus the probability of their intersection. So their intersection has only one element, which is 1. So that will give you 1 over 12. Then simplifying this expression, so 5 minus 1 is 4 over 12. So reduce 4 over 12 to its simplest fraction. That will give us 1 over 3 as our answer. Okay, so 1/3 is the probability of the union of events E and F. Next, we go to the next example. Make a list of the possible outcomes in each event if you roll a pair of dice. Then find the probability of getting, number 4, sum of 7, number 5, sum greater than 9, and number 6, the sum of 7 or product of 12. Now, first thing we need to do here is to determine the possible outcomes when you roll a pair of dice. Yun. Okay, so if we roll a pair of dice, the total outcomes or sample space is shown below. Okay, so we have each pair of possible outcomes, and if we're going to count them all, there are 36 possible outcomes, which will serve as our sample space from 1, 1 to 6, 6. Okay? Now, if we're going to consider them in terms of value, for the snake eyes pair of dice, that corresponds to 1, 1. This one is 1, 2. 1 dot and 3 dot corresponds to 1, 3. 1 dot and 4 dots corresponds to 1, 4. 1 dot and 5 dots corresponds to 1, 5. And obviously, this is 1 dot and 6 dots corresponds to 1, 6. As we go on, we will consider the so-called order pair up to 6, 6. And to count them, we have 36 possible combinations, 36 possible combinations of outcomes from 1, 1 to 6, 6. Yeah. So the number of elements in the sample space, which is n of S, is equal to 36. And we obtain 36 by listing. Or we could also obtain 36 using the fundamental counting principle. So you just simply multiply 6, which is the number of faces of a die, times the number of faces of another die. So that is also 6, which will give us a product of 36. Okay? Yeah. Now, then we find the probability of getting the sum of 7. For our solution, let us denote the sum of 7 as E sub sum 7. Then, let us consider the elements of an event of throwing a pair of dice having a sum of 7. Out of 36 possible outcomes, we have this one. We have 1, 6, 1 dot, 6 dots, or we consider the other way around, 6 dots and 1 dot. Another combination for the sum of 7 is 2, 5, 5, 2, or possibly we have 3, 4, and 4, 3. So all in all, there are 6 possible elements from this event. whose sum having a sum of 7. So to get the probability of getting a sum of 7, that is P of E sub sum 7. So looking at the set of E sub sum 7, there are 6 elements which will serve as our numerator for the value divided by the sample space, which is 36. Now let us take the next item, number 5. This time the probability of getting the sum greater than 9. And let us denote this as E sub 9 plus. Now such event has these elements. For each pair of die, a sum greater than 9 could be a combination of 4 and 6, 6 and 4, 5, 5, 5, 6, 6, 5, and 6, 6. So there are how many elements? 6 elements. So to get the probability of E sub 9 plus, we have for the numerator, that is the number of elements from this event, which is 6 over the sample space, which is 36. And reduce this fraction to its simplest form, that is 1 over 6, which is our answer. Next, number 6. How about the probability of getting the sum of 7 or product of 12? So let's just denote the sum of 7 as E sub sum 7. And the product of 12 is an event which can be denoted as E sub prod 12 or product 12. Now let us determine the following elements from each event. So for E sub sum 7, the elements are 1, 6, 6, 1, 2, 5, 5, 1, 5, 2, 3, 4, and 4, 3. So there are 6 outcomes or elements from this event. Another event is that there is a product of 12. So that is E sub prod 12. And the elements of these events are a combination of 2, 6, because if we're going to multiply them, the product is 12, or that could be 6, 2. Another combination of the pair of dice, we have 3, 4, and 4, 3. Okay, so we only have 4 outcomes now. So we have 2 events. Let us determine whether these 2 events are mutually or not mutually exclusive. So let us identify if there are some elements that are present uh, from or present to both elements. And we identify that they have a common elements of 3, 4, and 4, 3. So that is their intersection. So E sub sum 7 intersection E sub prod 12. The elements are 3, 4, and 4, 3. So from this intersection of 2 events, we have 2 outcomes or elements. So for the union of these 2 events, so since they have a common set of elements, we can therefore say that these 2 events are not mutually exclusive. So therefore, to find the probability of these 2 events, we have P of E sub sum 7 plus E sub prod 12 minus the probability of their intersection. So for this term, P of E sub sum 7, we have for for this event, there are 6 elements, so that is 6 over 12, 36 rather, plus E sub prod 12. So how many elements do we have here? 4 over 36. Since they are not mutually exclusive, we have to subtract their result by the probability of the intersection of these two events. And for the number of outcomes, we only have 2 over the sample space, which is 36. So if we're going to simplify this expression, so 6 plus 4 minus 2, it will give us 8 over 36. Then we cancel the greatest common factor of 8 and 36, which is 4. We're going to cancel their GCF. This fraction will be reduced to 2 over 9, which is our answer.